So this is what we are going to do. So far, I'm pretty sure you prepared those. You went through the preparation of week 5 that I provided here. You can see this, right? Preparation of week 5. This will require you, or this will guide you to download the data from World Bank, basically. I mean, this is not really difficult process, but the reason that I ask you to do is because sometimes it takes time, because we are about 20 people at the moment, and if we all try to download from the same source, it may take time. And also, whenever you download, based on how you access to the data, the result can be slightly different, and Uni experienced it just before, actually a couple of days ago. And then what we have gone through here in the World Bank data is basically downloading population and GDP and CO2 emissions. Why do we use World Bank data? There are other sources like IEA data source or EU or UN data source, but World Bank is one of the best database you can find, and they are well organized. Although you might find some data are not really organized well, or sometimes it unmatched between data, but still World Bank is one of the cleanest one you can find. To go through, for example, you can select population. You can use the code, or you can just type population here, and then you can go to data, and then select countries one you want to download, and then select the timeline you want to download. So what we need is just 2023 data set, nothing else. I mean, as Sejong explained before, actually to calculate carbon budget properly, we need long historical data, not just 2023. But we are going to use 2023 at the moment because we are making everything very simple. And in the end, after the next 4 weeks, you will understand how Plan 1.5 did the analysis. And then basically you can mimic what they have done throughout using the techniques that we learned during next 4 weeks, but it's a little more complicated there. And then we can add the times, and if we download the data, basically we can get population data and GDP data and carbon dioxide, just CO2 data as well. And we are not going to worry too much about other emissions like methane and the others. We are going to focus only on CO2. And we definitely need global carbon budget data. Usually you can get it from IPCC guideline, but IPCC guidelines updated only maybe 4 years or something, not really often. So you need some supplementary data set. Usually global carbon budget website, there is a website called Global Carbon Budget, and this is the one. If you access to their information, they update global carbon budget almost every year, quite fast, and they already have 2024 CO2 emissions, which we can use to calculate 2025 carbon budget. So usually we get data from there, the website, and then we needed to check a couple of things. First, do the files have same structure? The most important one, just I told you, is just because two files come from the same platform, it doesn't guarantee their structure is identical. So whenever you have the data, you need to actually open it and check the structure. And do they have the same number of rows, or do they have the same number of columns? And non-standard column names, for example, 2023 YR 2023. This is something also this is something that makes me not too happy whenever I use World Bank data set. Rather than using just 2023, they use this strange column name always. And you need to drop unnecessary columns. And those unnecessary columns include series name, series code, and sometimes country name, because we can use country code. Difference between country name and country code, right? So in case of South Korea, each country name is the Republic of South Korea, or Republic of Korea, or South Korea, or etc. There are a couple of different names that people normally just use. But if it becomes ISO code, South Korea is always KOR or just KR, right? In case of Singapore, it's SGP or SG, I think. Like, yeah. In case of United States of America, it's USA or US. So that's much clearer one, and that's much more well-structured code that we can use. And then we need to remove non-essential rows. Sometimes the last few rows are very unnecessary, and sometimes first couple rows include only those information which are not really relevant to, which are not really useful when we do the data analysis. Let's just see how this data might look like. Let me go to our data platform. And if we didn't go through the preparation, you can simply copy and paste. You can simply download this data to your local computer and then bring it, upload it to your Colab notebook driver. So, for example, if we download the CO2 emission data, it has series name and series code and country name, excuse me, country code and year. As I told you, year name is not, this column name is not just 2023, but it has bracket and saying year 2023. I understand why they did it, because sometimes it can be financial year. The financial year can be different from calendar year. So that's why I think they have this kind of structure, but still I don't like it. And then another one is this 2 dot. 2 dot means NA in World Bank data set. This is not the best way, but still, as far as data is structured in the same format, it's fine. We can deal with it. But if data has, sometimes NA is 2 dot, but sometimes NA becomes just NA. And if sometimes NA has like empty, then it is really difficult to change everything one by one. So bring it back to usual. And then if we go all the way down, we have this additional information. The reason that we need to check till the end is because if there is an additional information, Python will try to import data until the end of this row, row number 223. But because the structure is different and because there is an empty values here, we will end up having very strange structure. So we need to be careful about it. Okay, now download all the data from here, from our drive, and then copy paste to your Colab notebook drive. You can do it now. And if you have done it, please raise your hand just to make sure that you all have the data. Otherwise, you cannot follow the next step. Now we are going to import pandas library. Import pandas as PD. Then run it. We'll read line by line. Next is going to be defining a variable called path, which has actually the directory name. Everyone will have the same directory name at the moment. It will be exactly like this. I will wait here. If you have any trouble in running the next line, please let me know. So far, everything's okay, right? Everyone's following, right? Okay, great. You can just pop up. You can just pop up the question anytime if you have any trouble. And then we are going to import an Excel file using read Excel method from pandas. But we are going to save it to GDP underbar data frame. This is some kind of my own convention just to make sure what kind of data I use. Whenever I use data frame, I add underscore df as a short form of the data frame. But if I use dictionary, I use just dt. And if it's array AR or something like that to make sure what kind of data I have. But you don't need to follow it, but it's a good idea to have such your own convention to make sure you know what you are doing. And read Excel. So as it explains, in pandas module, it has method called read Excel. It does as it says, basically it read Excel file. And from where? From path plus what is the name of this Excel file or population is ny. Oh no, sorry, GDP mktp dot pp dot kp dot xlsx, right? And then let's try to run it, and then let's see how it look like. Okay, this is not what I expected at all. Path ny gdp mktp pp dot kd xlsx, and let me double check it. I guess almost everyone has the same problem here, right? Let's go back to Drive, and my Drive, Google Colab notebooks. Oh, I think I found it. Right? Yep. So uppercase and lowercase is very important in Python. So because I used this lowercase, it failed to find the path. Just because I changed it to the capital, now it has the proper, it basically imported the file successfully. But as you can see here, it has bit of problem. Seems so right here, the first row has the value of Afghanistan, and then Albania, Algeria, blah blah blah, and then it has NAN, which means no data, and then goes to data from database, world development indicator, and last updated data is what, something like this, which are not too useful for us. So we want to remove those, basically we want to remove those lines, those rows. But how? We can simply limit the number of rows that we want to import using argument or parameters 2 to 1, n rows 2 to 1, right? And then we can run it again. Still, it says the same. Why? Because it's not actually 2 to 1. It says it's 216. 216, I think. Let me double check it. Right? Ends up correctly with Zambia. Oh, I missed one. 7. Zimbabwe. ZWE. That's the last country we have in our data set. Now, to make things clearer, going to remove it and then jump into the next line. We'll do the same for CO2. Plus,
Sanya,
Hello? Yep.
Hang on. So for this file, can you show them how they can just directly copy and paste the file path? Because some people are still having problem uploading the file, reading in the file. So if you go to your drive and then, so like that file that you're trying to read. Yep.
So
no, not your drive, but on your Colab notebook.
Okay.
Yeah.
So
yeah,
here is
copy.
the file name. For example, if I want to have NY file here, go and copy the path. Then you can paste it here. Then you will see the entire path, right? Other than having path in front, the other way you can do is just copy and paste the entire path of the file directly to your in the parameter of read Excel method. Then you can read it the same way.